Okay, so today we are going to work with the mold assembly on the ejector system. Alright, so before we start, we will have to call out the mold assembly and hide away the plate that we don't need. So we will only display what is necessary. Unpack this. Alright, so we will see them all. Right, so fix half, no need to see. Move half, core plate, no need to see. Spacer block can off. Ejector retainer plate can off. Back clamping plate can off also, like this. Okay, so then we have the layout side, right? We will hide away the cover cavity also, cover cavity. Okay, so we have got that, and the runner also can hide. Okay, so we have this display on the screen like that. Okay, with this we can measure the distance between our ejector have to go there, right? That face, right? So you can, these two face is the same face, so you can pick this face and this face, right? You will get a minimum distance of 117. So record this number now, down 117. All right, so the distance between this one we can close, this one can close, right? Then distance between this face to this face, all right, is 135.207, 135.207. So record this number also. Okay, so yeah, that's how we start, by measuring the distance. Okay, so if we go to the lab notes, right, you go to ejector assembly PDF. All right, that's where it's telling us open the mold system, mold assembly work part. All right, then untick all, take only this one, bottom clamping plate, core ejector plate, core insert. All right, so we need core insert and ejector plate. Measure the following distance, record the value. So this is what we just did. Okay, so download the pin from the part that you download the pin, or we draw the pin also can. All right, so then we will change the file to layout. Then we need to create a part called ejector. Okay, so over here we will make the layout work part, make it open a new window is better, huh? Open a new window, so we make a display part like this. Okay, so then we will create, go to assembly, make a new component under the same folder. We call it, okay, your admin number, D2 admin number ejector. Okay, empty node, just say okay. So we have got a ejector file inside there. All right, having done the ejector file, we will bring in the ejector pin. We can don't see the cavity plate, we can don't see the cavity insert, don't see the cavity core, the cover product, right? So we see only that. Okay, so now we are going to bring in the ejector pin to this sub assembly called ejector sub assembly. So we make the ejector sub assembly work part. Okay, so yeah, we will control L, layer control. I have to show the datum, so it's easier to work. Okay, okay, so my datum is on layer 61. Control L on layer 61. That's what I did. So now we have to start to bring in the ejector. So ejector, I will demonstrate here uh, a few, so that you got an idea of how to do. All right, I won't do it all. I just show you how to do. So we will add a new component, add component. All right, with the ejector pin that we have just downloaded or just drawn. Take a ejector plate, ejector pin. All right, of diameter 3.5, length 117. Okay, so we will bring it in, so it will just sit there. Okay, so do a F8, so it is coming in at the absolute 0 point now. Okay, let us move it somewhere here. So I just specify the orientation. Okay, click on somewhere around this area that we want to put the ejector pin, center around there. Okay, so agak-agak, oh, I've clicked wrongly, yeah. So specify orientation, right, left click here. Okay, then it will come over. Then we can do the fine tune later. Okay, by measuring it properly. Okay, it will stay fixed. We just accept it for the time being. Later we can get rid of it. All right. So ejector pin. Under the ejector pin assembly, we have a part called the diameter 3.5 ejector pin by 117. So this one, the fix, we can remove it. Okay, click this one, right click, remove, delete. All right. So I delete away the fix. Okay, so now we bring it in like this, one piece. Okay, so how to work with this, right? There's a couple of ways, but I will show you how to do it um, with expression control, dimension control. So anytime we will be able to capture the actual size and it is embedded in the expression. So assembly constraint, the measure distance, right, between this datum, from this datum to this datum. All right, so this is, I think we can try 117, see, then it go up, right? Then we can put it minus 117. Apply, right? It will go down. Okay, so that's one done. The distance is done as of like the height is sorted. So we have to sort out the x and the y. X and the y, normally I like to put it in such a way that they are round figure, so that when the machinists do the drilling, they will be able to capture uh, round figure to, so we try to eliminate decimal point even at the design stage or placement stage. So let me just zoom in to see clearer. So this one is a bit offset, right, to the side. So we will slowly tune it back. Assembly constraint, distance between, we have to pick the datum plane. We have to pick the datum plane and it will work. Pick the datum plane from this datum plane to this datum plane. Alright. So this distance, okay, meaning this parallel distance here. Okay. Okay, so the blue distance now is 26, right? We can adjust, zoom in, have a look. Let's say we put 26.2. Then it was this area and this area, there is still a little bit, we can move a bit more, 0.3. Okay, so they are more or less equal now. So eyeball it, this side and this side, they are almost the same lah. So 26.3. Okay, so that is the distance on the y direction. Okay, home key to bring back to isometric view. So next we will do the dimension, all right, of this datum to this datum. All right, so it will determine the x direction. Okay, we can give it again. I think I recorded already, so lost it. So double click, come over here, double click on the last one, right? So I try to put it to 20. See how it goes. So let us zoom in, have a look, see how it goes. All right, so yeah, I'm almost at the edge here, so that's where I want. Okay, so all of you decide on which location that is going to be. So yeah, that is a piece of ejector constraint in terms of x, y, and the z. All right, so you show degree of freedom this ejector pin have no more degree of freedom because we have fully, there is no degree of freedom because we have fully constrained it, right? So that is one piece done. So we have to continue to do for the rest. All right. So doing one by one is easier. If you try to do all together, it gets very messy. Okay. Let me show by adding in one component on the diameter 5. Diameter 5. So diameter 5, I would like to put one piece here, one piece here around here, this area to eject the main area. So I place it around here. This is the center, right? Can you imagine down here the center? So I will diameter 5 around here. So I just click around here. Okay. I think I better discard this. I think I click wrongly. One more time. Add component. Pick D5. Okay. So the selected part should be one only. So under the placement, go to specify orientation. Pick somewhere around here. Okay, it should come in and say okay. So I bring in one piece of diameter 5. So it will be like that. Okay. So then we have to do the same process like before. Assembly constraint between this face to this face. So minus 117. Right. Then the x and the y. So in the x direction, pick this one and this one. Okay. So give it a round figure. It's around 26. 26. Okay. And distance between this datum and this datum. Alright, distance around 15. You can always come back and edit later. Okay, let's check from the view. See how close is it to the edge, right? So this is diameter 5 ejector pin. Alright, with the different distance stated there. Okay. So we can go to analysis, measure, right, between this edge, right, to this edge, to this face. Okay, what is the distance? The minimum distance is 117, right? Sometimes this distance doesn't make sense, right? Or this is not what we want. Okay, so you can go to the more, all right, down here. Okay, click the arrow down, then setting, preferences, on display x, y, z and delta value. Okay, then we will see x, y, z and delta value. This will reflect better, easier to read in terms of delta x and y and z. Okay, so then we know the distance, right, in terms of y direction is around 2.6. The x direction is around 3.1. So we know it is actually quite far away from the edge, so we can use that. Okay. So record this position at the XY position, then we can use it for the other side. So the same process would apply to the other pin that we have to add in. Okay. So please do the rest on your own. This two is only a demonstration of how to go about adding it in. Right. So we have two pins added like that.